So welcome to the course of electronics and control race. In the last class we started the unit 4. In that we discussed about the various speed control techniques stator voltage control method and frequency control method, speed control method. As per our syllabus in the unit 4 having the stator voltage control methods. Here the first one is the stator voltage control method. That is the stator voltage control by using the AC voltage regulator in our syllabus. So before going to discuss about the stator voltage control method by using the AC voltage regulator, so in general the conventional methods to get the variable voltage. Here one thing is that whether it's the conventional methods or AC voltage regulators, our aim is to get the variable voltage from fixed three-phase AC supply. To get the three-phase AC supply to the fixed AC to variable AC, there are so many methods are available. The conventional methods are the first one. With the help of the auto transformer, we can get the variable AC. In the laboratories, we can see that whenever the three-phase supply is given to the auto transformers, by adjusting the variac, then we get the variable voltage. Then the variable voltage is given to the induction motor, then speed of the motor can be controlled. We already seen in the electrical machines 2 lab. In the similar way, in order to get the variable voltage, another method is that is we are inserting some rheostats to the input side of the three-phase induction motor. That means we are connecting the primary resistors are connected in the starter winding. And the starter winding three-phase induction motor la undanukondi. Three-phase induction motor direct ga three-phase supply direct ga avukunda direct isthe avutundi. Direct supply తీసుకుని అంత స్పీడ్ దొరుకుతుంది. బట్ నాకు వేరియబుల్ స్పీడ్ కావాలి కాబట్టి సో we need some rheostats in this fashion. సో డైరెక్ట్ సప్లై అవ్వకుండా ఇలా అడ్జస్ట్ చేస్తాం. త్రీ ఫేసెస్ కి కూడా మనకి ఇలా ఉంటాయి. సో త్రీ-ఫేజ్ సప్లై. సో అలాగే మనకి ఏ ఫేస్, బి ఫేస్, సి ఫేస్ కూడా 3 rheostats విడిగా ఉంటాయి. ఎప్పుడైతే మనకి ఈ 3 rheostats ఉన్నాయో, by adjusting these rheostats we can get the voltage drop takes place, therefore we get the reduced voltage from the starter. Then we can control the speed of the motor. Okay, whenever we are giving the fixed voltage, ఎప్పుడైతే ఫిక్స్డ్ వోల్టేజ్ ఇస్తున్నామో ఈ రియోస్టాట్ దగ్గరికి వెళ్ళి వోల్టేజ్ డ్రాప్ అయ్యి ఆ వచ్చిన వోల్టేజ్ డ్రాప్ అవుతుంది వల్ల వోల్టేజ్ తగ్గి మనకి రెడ్యూస్డ్ వోల్టేజ్ వస్తుంది కాబట్టి ఇండక్షన్ మోటార్ ఏదైతే ఇక్కడ ఇండక్షన్ మోటార్ ఉంటుందో ఆ ఇండక్షన్ మోటార్ త్రీ-ఫేజ్ ఇండక్షన్ మోటార్ అనేది సమ్ లో స్పీడ్ తో రొటేట్ అవుతుంది. ఇస్ ఇట్ క్లియర్? సో దిస్ ఇస్ ద మెయిన్ advantages of primary resistor while connecting the three-phase supply of the three-phase induction motor. But the drawback in this case is whenever the rheostat is adjustable, then we can get the voltage variable. But the problem is here that the rheostat itself taking power loss takes place. Due to the higher power loss, due to the resistive property of this resistance, so there is a possibility of high power loss. Therefore, the losses are more. In case of auto transformer, the cost involved is more compared to the motor also in some cases. Therefore, both the conventional methods like three-phase auto transformer method or otherwise the primary resistors are connected in the three-phase induction motor, both are failed in nature. So that's why we go for the next method is called as starter voltage control by with the help of the AC voltage regulator. In the AC voltage regulator, we are having if the motor having the starter winding star connection like 1, 2, 3, A phase, B phase, C phase, like star connection, A phase, B phase and C phase, and the A phase is connected, B phase you are not giving any three-phase supply direct to the A and B, C. With the help of this AC voltage regulator, especially three-phase voltage regulator, especially three-phase voltage regulator having two, it may be half wave or it may be full wave. We are using the three-phase half wave here. Three-phase AC voltage regulator, three-phase supply is given to three-phase half-wave AC voltage regulator. Through this, they are giving the supply to the corresponding starter winding of the three-phase induction motor. Then we can control the speed of the motor here. No need to discuss about any operation in this three-phase regulator, but it is not in our syllabus. The three-phase operation in the previous semester we have already studied it there. So no need to discuss about the three-phase AC voltage regulator here. So whenever the three-phase supply is given to this AC voltage regulator, this is off wave because of one is thyristor, one is the diode, another is thyristor, diode. Is the combination of thyristor and diode is called as off wave. If both are thyristor, that is called three-phase full wave. That means three-phase full wave exam అడిగితే three-phase full wave అంటే రెండు thyristor వేస్తాం, ఆఫ్ వేవ్ అంటే ఆఫ్ వేస్తాం. ఒక స్టార్ కనెక్షన్ కాకుండా డెల్టా అంటే డెల్టా కనెక్షన్ వేస్తాం. So because of while in case of delta connected loads, what happened is for delta connection fashion, there is a third harmonic present. Due to that third harmonic, which is caused due to the presence of back EMF, therefore there is a circulating current flowing in the line of the స్టాటర్ వైండింగ్ ఆఫ్ 3-phase ఇండక్షన్ మోటార్. ఎప్పుడైతే మనకి ఈ థర్డ్ హార్మోనిక్స్ అనేవి ఇంజెక్ట్ అవుతున్నాయో ఆటోమేటిక్గా మనకి లైన్ ఏదైతే కరెంట్ ఏబీసీ లైన్ కరెంట్స్ తీసుకుంటుందో ఆ ఇండక్షన్ మోటార్కి స్టార్టర్ కంపల్సరీగా అక్కడ కూడా హార్మోనిక్స్ ఎంటర్ అయిపోతాయి. సో అందుకోసం మనం డెల్టా వైండింగ్ అనేది ఎక్కువ ప్రిఫర్ చేయము, స్టార్ వైండింగ్ ప్రిఫర్ చేస్తాం. దట్ ఇస్ మెయిన్ ఇంపార్టెంట్. Again, the one advantage there in case of delta connected is because of the delta connection we know that phase voltage is equal to line voltage, but the line phase current is equal to line current by √3. Because of that reason, it draws less amount of current. Therefore, the design point of view, the size of the conductor also less in the case of delta connected because of I phase is equal to I line by √3. But is not happened in the starter winding. That is the drawback in the starter winding. Starter winding lo aithe I phase is equal to I line, delta winding lo I phase is equal to I line by √3. I line by √3 కాబట్టి magnitude of current తక్కువ ఉంటుంది కాబట్టి మనకి డెల్టా వైండింగ్ ఇన్స్టలేషన్ కాస్ట్ ఇవన్నీ వైండింగ్ కాస్ట్ తగ్గుతాయి. సో ఇస్ ఇట్ క్లియర్? బట్ హార్మోనిక్స్ మాత్రం ప్రెసెంట్ అయి ఉంటాయి. సో దిస్ ఇస్ అబౌట్ ద డయాగ్రామ్ ఆఫ్ స్టార్టర్ వోల్టేజ్ కంట్రోలర్ by using the AC voltage regulator. Is it clear? The 3-phase is not directly given. With the help of this regulator, we can control the speed. Okay. Here the thyristor 1. Let us say this is the thyristor 1 and 3 and 5. This thyristor 1, 3, 5 both with respect to supply all are displaced from 0, 120 degrees, 240. Each having a phase displacement 120 degrees. Similarly, 1 and diode here is having a phase displacement of D4. Let us say D6 and D2 is having a difference of 180 degrees. ఈ థైరిస్టర్కి డైరెక్ట్ 120, ఈ థైరిస్టర్కి డైరెక్ట్ 180 ఉంటుంది. ఇది కూడా 180 సారీ. బట్ ఈచ్ థైరిస్టర్ T1, T3, T5 which is displaced by 120 degrees to each other. So this is the construction details of the 3-phase starter voltage controller by using the 3-phase AC voltage regulator. In the next class we are going to see the what is the how to draw the torque speed characteristics with the help of these regulators.